minute or so. So that meeting has now been recorded. So as I say, I'm George Laurie. I'm Vice Chairman of the International Barley Hub. Been involved in the Barley Hub from its conception, really, and happy to see as many joining us today in what is the start of our 2020 seminars. We've got the seminars divided into two now. We've got the seminars where we have technical, very, very technical seminars at the end of the month, and we have our other seminars which are not just quite as technical but still giving good information about the Barley Hub and what the Barley Hub can do with barley. So we have them as well. So please keep an eye out on our website, and we can help you to log into these seminars. Today it is a great pleasure to welcome, I can class Pete as an old friend of mine. Pete and I worked together for a long time, and I was involved with Pete when we were reviewing the RB 209 fertiliser guide. So I've been involved with Pete for a long time. Pete is head of crop physiology at ADAS. Pete's research aims to improve performance and reduce pollution of cropping systems through the understanding of crop physiology, plant breeding and agronomy. He is an author of 40 peer-reviewed research papers on the crop physiology. So Pete has got a big background there. He works out of York with ADAS, but at York, and never has a time been so relevant to talk about the minimising of crop lodging. With inputs at their absolute highest I've ever seen them in the industry. This is going to be a very interesting talk because there's still this balance between gross margin and input of and inputs as well. So Pete, I'm going to hand you over, and I'm going to be one that's really going to be listening to this one just to see how I can keep my crop standing but still get the yield out of it as well. So over to you, Pete.
Thanks, George. Thanks for that nice introduction. Share my screen. Okay. Can you see that slide okay, George?
Yes.
Excellent. Right. Well, thanks for inviting me. It's a great pleasure to be with you. Lodging was something I got into over 25 years ago when I started my PhD. I was sort of looking around for something to do. I wanted to do a PhD in something practical, and this one just came up, which was just right on the street. I was interested in weather, I was interested in maths and engineering, I was interested in crops, and lodging did it all for me, really. So my PhD was all about predicting lodging risk in cereals, and well, I've never looked back in terms of lodging, really, because I've carried on with this strand of research ever since. So what I'm going to present to you today is a summary of our work we've done fairly recently on spring barley, and as you'll see, I'll give you a certain background about how it all emanated from our earlier work on wheat as well. Hopefully it's something a bit different for you all, and I'm looking forward to a good discussion afterwards. So when you think about lodging in cereals, it's vital really to start with how it's caused. And it's really important to remember that it's not just about buckling of a stem. That's often the perception, that lodging is all about stem buckling. But in actual fact, root lodging is probably more common and certainly causes the bigger yield losses. So, oh, sorry. I'm trying to get my laser pointer up. There we go. So root lodging is the most, yield limiting type of lodging, and it occurs after just relatively little amount of rainfall. Several millimeters is enough to wet up the top few centimeters of soil and weaken the soil enough to cause root lodging. Stem lodging is something which occurs more frequently towards harvest. The stem strength of any cereal crop basically halves in strength from about flowering until harvest. Of course, in barley you've got brackling as well, which we define as the buckling of the upper third of the stem, also got necking as well, of course, sort of a buckling just below the ear. So you got all these things to contend with dealing with and understanding lodging. We try and boil it down though into something a bit simpler, where because it can get just overwhelming, because you've got things like the wind, the soil type, the rainfall, agronomic factors, and then you've got all the plant characteristics as well. It becomes very complicated if you're not careful. So we try and boil it down to saying that root lodging will occur if the wind-induced leverage of a whole plant exceeds the strength of its anchorage system. So we're looking at root lodging occurring on a sort of per plant unit scale. And really important within this is the anchorage system. So we found that the strength of an anchorage system can be determined by the spread of the root plate and its depth. And that root plate is defined by the regions of crown roots which have an area of secondary lignification. So that means they've got, that's denoted by the riser sheath, which is around the outside of the root. And you can tell which parts have got that secondary lignification because they've got soil stuck to them. They've got soil stuck to that riser sheath. Once you get to the extremities of a root, these provide no anchorage properties really. They're purely for acquiring water and nutrients. So it's these top few centimetres. So this depth might be anything between 3 and 7 centimetres deep, and similarly the spread might be anything between about 4 centimetres up to 11 or 12 centimetres for a plant grown at low plant density. So this is really important. Anything we can do to improve this helps with reducing lodging risk. In a similar way, stem lodging we assume occurs if the wind-induced leverage of a shoot exceeds the strength of the stem base. And the strength of the stem base is really important, as you'll see later. Of these three parameters, wall width, material strength and diameter, it's really the diameter which has the biggest bearing on the strength of the stem. The wider the diameter, the stronger the stem. And then this in many respects is the more complicated bit. This is when we first started our research on lodging, we teamed up with a group of wind engineers who started at Nottingham University, and then they moved to Birmingham University and still are at Birmingham University. They've been focusing their work on modelling wind throwing trees and modelling the sort of movement of tall buildings and things like that. And they were able to apply their knowledge to cereal plants. I'm quite happy to move on to cereal plants, actually. I think they were finding trees a bit complicated. But what they applied, and the principles they applied, was to say that a shoot like this, when you sort of impact it with wind, then it oscillates, and it oscillates at a certain natural frequency. So this is measured in hertz. It's the number of oscillations per second. And the more rapidly a shoot oscillates, the smaller the leverage it exerts on the base of the plant. And when you think about it, farmers and breeders all do this. They sort of do this brush test, don't they, when they walk through a series of variety plots, just to see how the plant oscillates. And it's their way, I think, of sort of maybe unconsciously measuring the natural frequency of their plants. So it's a well-known engineering term, and it can be used to work out the leverage force of the shoot, together with the area of the ear, height at centre of gravity of the plant, and the speed of the wind impacting on the ear. So in the sort of early days, we developed a model of lodging. Naturally, it accounts for the rainfall and the soil type, which together determines the strength of the soil, wind speed. And then we've got these parameters of the plant. We've got the spread and depth of the root plate. We've got the crop height, its yield, and its shoot number, which are used to calculate those engineering parameters: natural frequency, height at centre of gravity, ear area. And then we've got these stem properties, which are related to the strength of the stem. And then we can use that to work out these components of lodging, which are the strength of the anchorage system and the stem strength and the leverage of the shoot and the plant. From that, you can work out the risk of lodging. And our wind engineering friends like to calculate lodging risk in terms of something called a failure wind speed. So that means the wind speed at which the crop will lodge. And the higher that failure wind speed, the less likely it is to lodge. We've since sort of further developed the output of the model. So it calculates lodging risk in terms of the effect on the recommended list lodging resistance score. So you know that all the varieties on the recommended list are rated on a 1 to 9 scale for lodging resistance. Generally, they're sort of 6, 7, or 8 out of 9. And we've developed the model so that it calculates the impact of lodging risk in terms of that recommended list lodging resistance score scale. So it means something to farmers and agronomists. And the reason we went to such great lengths to develop this model was because we've been doing lots of research on how crop management affects lodging risk, and you do all these field trials, and the only way you could gauge lodging risk was if lodging actually occurred. And like 9 times out of 10, there's no lodging, or when it did occur, there's so much lodging, but all the plots lodged. So you're still none the wiser as to whether what crop management factors were having the greatest impact on reducing lodging risk. So this approach allowed us to do those sort of crop management trials, grow the crops in different ways, and then measure these crop characteristics in each plot, plug it into the lodging model, and calculate the lodging risk. So then we can calculate the impact of, for example, sowing date and seed rate and nitrogen rate on the lodging risk without relying on natural lodging occurring. And that's what you'll see a bit further on in the talk. I'm always very skeptical about models. You know, I mean, you can really sort of start to believe your own model if you're not careful. So we did go into a lot of effort to test it in the field. This is one of our portable wind tunnels we put in the field. It's got some fans in the back here which blew the wind through to this observation chamber. We stuck strain gauges on the plants. We had a sonic anemometer. We had an irrigation boom in there, really just to check that the calculations of the model and how it predicted the risk of lodging actually met with reality. And we used this to calibrate the lodging model. That was 20 years ago when we were doing that. This is more recent sort of tranche of research where we developed a model for other crops such as oats and maize and oilseed rape. And we've got better ways of doing it now. We've put sonic anemometers in the crop, as you can see here in this photo. We had various video cameras set up, and we painted parts of the plant so we could see them oscillating in the wind. And by strain gauging the plants as well, you can sort of put the whole system together and test whether natural wind conditions, rather than those induced by fans, are well predicted by the lodging model. So this is work we did not that long ago, really, with Birmingham again and Lancaster to develop the model for some of the crops. And it's sort of a rich area for papers, really, because it's a nice interaction between disciplines of engineering, agronomy, and it's led to a lot of papers really in different areas. And we've produced the model so that it can work, for example, in Mexico on irrigated wheat. One of that middle reference there, we developed it for all the crops I mentioned, maize and oats and oilseed rape, as well as wheat. Papers on sunflowers as well. And most recently, we've been using it to look at the effect of different agronomic factors on maize lodging. So let's move on to barley. That's the background. So we've used that model approach to assess how different management factors affect lodging risk in barley. We carried out a number of experiments over the last few years, looking at different varieties, seed rates, nitrogen timings, and we've also had a separate set of experiments looking at Brackling. These were all funded by BASF, and we're sort of now in the process of developing a spring barley lodging guide with BASF. For Brackling experiments, we focused on a variety called Sassy, which is the most Brackling prone variety on the list at the moment. So all these trials were done at one of our sites in the Midlands. Give you an idea of the sorts of yields we're getting in the experiments. This is the varieties we looked at. We chose varieties with a range of lodging resistant scores. Concerto was 6 and Irina was 8. At the time when we did this in 2018, they've actually changed the lodging resistance scores now, but we wanted a range of lodging resistance scores. Laureate and RGT Planet was somewhere in between. These are sort of yields we're getting, so you can see, reasonable yields. Seed rates we looked at, they from 100 seeds per metre squared up to 600, and you can see that the optimum lay somewhere between 200 and 400 seeds per metre squared, as typically is often the case. We looked at nitrogen rates from nothing up to a super optimal amount of 300 kilograms of N per hectare. You can see the optimum was somewhere between 80 and 150. You can see it's a very nitrogen responsive site that we worked on here. And we looked at nitrogen timing, and that was in terms of how much nitrogen was applied in the seedbed. So we either looked at all of the nitrogen going on in the seedbed, in this case 110 kilograms of N per hectare, or 40, and the rest going on at late tillering, starter stem extension, or nothing going on in the seedbed, and all of it going on at tillering and the starter stem extension. And you can see the impact of not putting any N on in the seedbed was a lot. It reduced yield by a tonne per hectare. In terms of heights, and I should say we measured all the lodging associated parameters: the height at centre of gravity, ear area, natural frequency. I'm not going to present all that. I'm going to sort of give you a potted version of what we did. But you can see the heights here. You've got the most lodging prone variety was Concerto, so it's the tallest, and Irina was the least lodging prone, which is the shortest. But that doesn't tell the whole story. The strength of the stem and the strength of the anchorage system do have a big effect. You might be surprised to see that the lower plant population had a higher height than the highest plant population or highest seed rate. That I've seen before, and I've seen it in the published literature as well. Lower plant populations in barley do often end up being taller. For the nitrogen rates, as you might expect, the more nitrogen we put on, the taller the plants, and avoiding any seedbed N down here reduced height by about 60 millimeters. So you're getting a significant reduction in height from not putting any N on in the seedbed. And then if we look at the strength of the stem, so stem strength is measured in something called Newton millimeters. We use a 3-point bending test here, where we measure the strength of the bottom internode and the second to bottom internode. This is the bottom internode data here. You can see there isn't much variation between varieties there in the stem strength. There is a big variation in stem strength as you change the seed rate. So the higher seed rates have got a much reduced stem strength, and that's because if you've got lots of stems growing in close proximity to each other, they're all competing for light and resources, and you end up with thinner, weaker stems. If we increase the nitrogen rate, then we're reducing the strength of the stem. And also, if we avoided seedbed N, we also increased the strength of the stem. And all of that really is related to the number of stems that you get when you change the nitrogen rates and nitrogen timings. The fewer stems you have, the stronger the stems by the summer. So this is an example of what we've done with one of the agronomic treatments. So we've used all the information that we've measured on the plant, the stem strength, the height of center of gravity, the ear area, etc., to work out, plug those into the lodging model and calculate the stem failure wind speed. So you can see here that as you increase the seeds per meter squared, so the stem failure wind speed in meters per second goes down. So it becomes more likely that lodging is going to occur. And we did the same sort of exercise for all of the other agronomic factors: the nitrogen rate, the nitrogen timing, and the variety. So you can see for the nitrogen rates, you can see how increasing nitrogen rate, significantly, as you might expect, reduces the stem failure wind speed. And, we know it reduces the wind speed or makes it more lodging prone, but this actually quantifies just how much those changes are affecting the lodging risk. And then finally, avoiding the seedbed N does increase significantly the stem failure wind speed. So this is just one year I've shown you here, but we've got 2 years. I'm not going to show both. I'm going to sort of draw them together in the conclusions. So what we find is that if you were to increase the seed rate by 100 seeds per metre squared, then that's equivalent to reducing the varietal lodging resistance score to stem or root lodging by between 1.5 and 2 points. So it's telling you that if you started off with a variety with a lodging resistance score of, let's say, 7, and let's say you were sowing it at 400 seeds per metre squared, if you drop that seed rate down to 300, then its equivalent lodging resistance score would rise to between 8.5 and 9 points, because you're going to increase it from 7 by 1.5 to 2 points. The nitrogen fertilizer rate, if we were to increase that rate by 50 kilograms of N per hectare, then that's equivalent to reducing the varietal lodging resistance score by 1 point for stem lodging and by 0.5 point for root lodging. And it's different for stem lodging and root lodging because the fertilizer had a bigger influence on the strength of the stem than the strength of the anchorage system. Delaying the first split, so you didn't put any on in the seed bed and you delayed it till tiller in growth stage 30 timing, that increased the stem lodging resistance score by a large amount, 2 points. But it did reduce yield by 1 tonne per hectare. So I wouldn't recommend doing it unless you've got a very, very high lodging risk where you've got a lot of residual nitrogen in the soil. And then finally, we calculated that using a PGR to shorten the crop height, if you reduce the crop height by just 5 centimetres, which is pretty typical for a standard PGR, maybe a bit on the short side or a bit on the low side, that would increase the lodging resistance score by 1 point. So you can see how this information can be used to develop a lodging guide where to help farmers and agronomists put together a strategy with a variety and a PGR program, seed rate, and nitrogen timing to minimise the risk of lodging in different conditions. I'll finish up with a bit on Brackling. I've been getting asked questions on Brackling for years, and just hardly any data on Brackling to be able to answer them. So these trials here were the first time I've actually got some decent data to talk about Brackling. What we did was to set up a few field trials looking at potential Brackling control treatments. So we looked at late PGRs applied at growth stage 37, lots of different products, and we looked at late fungicides as well, with the idea that maybe they could strengthen the top of the stem and reduce Brackling. And the first trial we did have a decent amount of Brackling in it, so we had something to go at. The blue spots are results of our assessment of Brackling just before harvest on the 29th of July. And you can see the relationship between the amount of Brackling in each plot and its yield. It's a pretty strong relationship there. We kept the trial going for longer than it would normally have done, so to maximise Brackling. So it sort of kept going after the surrounding farm crop had been combined. And so these are the orange dots measured about a week later. And you can see you've still got a relationship, but it's not quite as strong. So the products which did best, PGR products, the best one was Turpal. So you can see here in blue column, this is the assessment done at the end of July. 50% of the area was brackled without any PGR. With the Turpal, it's down to virtually nothing. Medax Max was also effective, reducing it from a fairly significant amount as well. So, the PGRs were effective, and they were effective by shortening the plant. We also measured the strength of the peduncle, but we couldn't see any effects on the strength of the peduncle, which were consistent and, that significant. Impacts on yields as a result of Brackling control were approaching 0.7 tonnes per hectare. So, our summary from the Brackling work was that 10% of your crop brackled, then on average it was reducing yield by 0.12 tonnes per hectare. So it's telling you that, if your whole field was brackled, you could be losing more than a tonne per hectare. And in our trials, we didn't get any sort of necking really and heads dropping off. So we were recovering pretty much all the crop. So it's a bit surprising really that it lost so much yield. But it's not to be underestimated, the Brackling, I would say, in terms of what impact it can have. The PGRs which were most effective were Terpal and Medax Max applied at growth stage 37. These were having some pretty sizable effects on the height of the crop. They're reducing height by 14 centimetres and 10 centimetres. And you might be thinking, wow, they must be over-regulating. But as you could see, they were actually increasing yield by over half a tonne per hectare. As often happens, you start with a great year, and then the next 2 years, we hardly had any Brackling in 2020, no matter how hard we tried. And in 2021, it lodged before it brackled. So that sort of confounded the experiment. I think it's always a good rule. If you get a good year in the first year, stop. Don't do any more experiments. You've done it. Yeah, so that's a lot. I'll stop sharing, and we can discussion.
Okay, thank you very much, Adam. Thank you very much, Pete, for that. That was very interesting. First question I've got to ask is, there's a big move to low soil movement. So going away from the plough to strip tilling or min tilling. Have you looked at, is there any difference in the root establishment within these cultivation traits?
Yeah, I mean, we haven't looked at it specifically, no, but zero tillage, anything which doesn't disturb the soil as much, should result in stronger soil and a reduced risk of root lodging, so that the soil should remain stronger. And there are some papers from years ago which have looked at different cultivation systems on lodging risk and shown that zero tillage at least reduces the risk of lodging. Strip tillage, that's debatable, isn't it? Because you're still sort of disturbing a soil in the zone where the seed is sown. So yeah, that might not have the same sort of effect as pure sort of slot drilling as a direct drill.
Okay, we've just had a question come in here from Helen asking about the interesting effects of BGRs on Brackling. I had only previously seen work on fungicide effects. Do you measure any effects on fungicides in your Brackling experiment?
Well, we did have fungicides, late fungicides in those trials, and they didn't have any effect. I do know of trials done in Ireland, for example, which have seen reductions in Brackling from late fungicides. Basically keeping the stems sort of integrity intact for longer. So there's certainly a rationale for those working. But in our experiments, we didn't see any effects. Maybe we didn't have as much disease as they get in Ireland.
Okay, we then move to Luke's looking at the difference where the varieties in the lodging yield trade-off. Have you looked at winter barleys? But I presume you're looking at both spring barleys and winter barleys in your trials?
No. Winter barley is sort of a bit of a poor relation here. We've done lots on wheat, and we've done a reasonable amount now on spring barley, but we've done very little on winter barley, unfortunately. So I think the same principles would be applying to winter barley as they do to spring barley, but we've done very much. I mean, what I would say about the varieties is that when we did all our work on wheat, what was really telling was the big genetic diversity in stem strength and anchorage strength of different varieties, which just isn't measured by anybody because they're not easy things to measure. but there's a tremendous amount of genetic diversity for breeders to go at and improve lodging resistance by improving stem strength and anchorage strength. Finding genetic markers for those traits proved to be a challenge, particularly anchorage strength. You know, it's hard to measure, and then it's obviously a very sort of a polygenic genetic control for that characteristic. So it does present somewhat of a challenge. But you know, I think it's a good area for geneticists to get into because we can't carry on reducing height forever. We want to increase yield. So how are we going to sort of keep our crop standing? Well, it's got to be through strengthening the anchorage and strengthening the stem. So we need ways of doing that, either understanding the genetic control better and getting genetic markers, or developing better phenotyping methods for rapidly phenotyping those sorts of traits.
Okay, I've got two questions from Laura. The first one is from a breeder's point of view. But there's Laura. I was wondering if there's a relationship between stem lodging and brackling. Are varieties prone to one also susceptible to the other? Are there shared traits that could improve both? And then Laura goes on to ask about the interaction between genetics and nitrogen sowing densities. So she's got two questions there, Pete. I don't know what you want to take. I'll just
you tend to find that if the bottom internode is weak, then all internodes are weak. So I would expect that a variety which is prone to stem lodging, i.e. buckling of the lower internode, is also more prone to brackling. When you look at the recommended list and the lodging resistance scores for spring barley and brackling, the sort of brackling score and the lodging score don't relate that well generally. And I think that's probably because the lodging score is an amalgamation of stem lodging and root lodging. So, you know, you wouldn't expect it to relate very well necessarily to brackling. Yeah, your question about actually, could you just unmute yourself and just ask your question about genetics again, the other one again?
Yes, thank you for this talk. I'm really excited because I'm working on the genetics of these traits in barley. So
okay,
so this is really interesting.
Yeah.
So one thing I was wondering, if you showed that basically low in nitrogen input or the timing of applying nitrogen fertilization and the density can reduce lodging, and we know this.
Yeah.
I was wondering if you have noticed that these treatments benefit more or less different varieties, that there is some kind of interaction between the management and the genotype.
We didn't have the experiment to test that because we only did those experiments with one variety, so we couldn't test it. Just trying to think whether we've seen any evidence anywhere else. Haven't, no. Because we've done a lot more experiments with wheat, for example. I never saw any interactions like that some varieties were more sensitive than others. Certainly we see differential variety sensitivity to PGRs. That's probably where the strongest interaction is.
Well, that makes sense because there might be some different physiological, let's say,
I think they have different
profiles,
hormone levels. Yeah, that's right. And but that wasn't straightforward either. You found that sometimes one variety was more sort of sensitive to PGR than others, but it wasn't consistent in each year. So there's a strong sort of a PGR by variety by environment interaction going on there as well.
Yeah, very complex, is true.
Okay,
thank you.
Thanks, Laura. Thank you. I've got a hand up here from M. Sanchez Garcia. Do we have a question there? There we are. Hi there.
Yeah, thanks a lot. Thanks, Pete, for the very, very nice presentation. Very interesting. Well, I'm Miguel Sanchez. I'm from the CADA Barley Breeding Program, the CGIR. Yep. Yep. And I have a couple of questions. I mean, lodging is a very big problem for us, and I will ask you two questions from the two angles of the lodging resistance. You said On the root size, on the root side, you said about this the angle of the lignified roots. It's important for the anchorage. In our case, we've used, I don't know if you're familiar with it, we've used the clear pot method to screen for seedling root angle. Do you know if seedling root angle could be linked to this adult plant root angle and anchorage? Because that's a trait that is very easy to measure for us, especially to measure in large number of germplasm. So that would help us very much.
Good question. I don't know. I don't know, I'm afraid. It would be very interesting to find out because, I mean, there's big varietal range of root plate spread. And it was partly, we found, due to the angle and partly due to the length of the lignified region of root. So it's a bit of both. God, yes, it would be incredibly useful if we could find that the seedling angle correlated with the mature root angle. Yeah, because see, you have to know that the lignification, the sort of root plate for anchorage is finally determined at about growth stage 39. So that's when all the lignification is complete by. So you need to sort of wait until you've got fairly mature plants to be able to see if the angle of roots in the seedling screen corresponded with those in the mature root.
I think you had another question.
Yes.
Want to go then?
Oh,
Yeah, I did, Pete.
Sorry. Helen, I think Sanchez had another question first, and then we'll bring you in, Helen. You had
That's
two,
okay.
Sanchez, and they'll bring you in, Helen, after that.
Oh, yeah, sorry, because I had two questions, just a quick one. On the other side, on the stem resistance for lodging, you talked about wall width, right? For a stem wall width for resistance. Do you know if this is increasing wall width is then linked to increased lignification in the straw? Because I know for Europe it's not a big deal, but for us, straw feed is very important for farmers. So.
Yeah, wall width isn't related to lignification. No, we have a parameter called material strength, which is related to lignin, but it's more actually related to the density of the stem wall material. So simply packing the cells more tightly and having a denser stem wall, that relates much better to the material strength. So lignin, we did do some experiments on wheat trying to correlate lignin amount with the strength of the stem. It didn't correlate that well, actually. Yeah, it's I think it's a bit of maybe a misnomer that lignin is critical. It's more about the geometric dimensions and the packing density of the cells, we found.
Thanks.
Okay, thank you. Helen, I really like your question. I'll let you answer that. I'll let you ask it in person. I really like your question.
George, yeah, it was just thinking of some of the effects of seed treatments and the biostimulant seed treatments and things like Vibrance Duo that increase early rooting.
Yeah.
Especially on wheat, we see more effects on wheat than we do on barley. Barley's pretty well rooted anyway. But I just wondered whether you'd looked at that or whether you'd expect to see any differences.
I'm just trudging my memory back on the Vibrance Duo work we did. Did find some effects of Vibrance Duo just to increase rooting generally, full stop, but we didn't actually measure those sort of anchorage parameters, so I couldn't tell you for sure whether it resulted in an improvement in anchorage. I mean, it's possible it could. So I don't know. I think this is potential. But we didn't measure that directly, unfortunately. Yeah,
it's really interesting work. Thanks very much for sharing it.
Thank you.
Yeah, my question kind of follows on from Helen's in that with the change of climate that we're getting at the present moment and the more extreme events we're getting, does stress, and when I talk about stress, I'm talking about either drought or waterlogging, does that affect the plant lodging capacity?
Not that much, I would say. I mean, we have just had a PhD student complete at Birmingham looking at the impact of climate change on the risk of lodging, and it's not that great, because the predictions for changes in wind speed are not dramatic. So that aspect of climate change, I think, isn't going to impact on lodging very much. Yeah, waterlogging and drought. I mean, drought could actually reduce lodging risk in that if it's going to sort of stimulate more root development, and crops might be smaller as a result of drought anyway. I think waterlog is an interesting one because that's going to inhibit root development at the time when it's trying to sort of grow its anchorage roots as well, particularly if it's sort of overwinter, early spring waterlogging. So I think that could increase the risk of lodging later on because you're just going to end up with poorly anchored plants. But by and large, I'm not seeing climate change sort of impacting that much on lodging in that way. I think a bigger issue with climate change is the warming, well, more for winter cereals this is, but the warmer autumn, warmer winters, more growth over those periods results in sort of, as we're seeing this year, really very lush crops for the winter cereals, and that is going to cause a big increase in the risk of lodging.
Okay, sorry, Pete, you've got me in a roll on this one. And one of the things that that's helped lodging greatly in the past 10, 15 years has been PGRs. So a couple of things on PGRs. One, have you looked at the timing of the PGR application to whether you do it before stem extension, whether you do it just on normal growth and things like that? So that's my first one. And the second one is that with reducing the height within PGRs, it encourages tillering. Does tillering help the lodging effect, or does that add to the lodging effect?
Yeah, I mean, for PGRs, I don't like going much before growth stage 30, really. I think you've got to have a stem starting to extend to have a reasonable effect from your PGR. And after that, your PGRs can be effective at any time up to growth stage 39, if you dare put it on that late before the ear pops out. I mean, for all my research on PGRs, I found that all the different products can be very effective. They're very fickle, though. They're very sort of reliant on the type of environmental conditions when you apply them. So my message to agronomists with PGRs is always to split and to mix actives to sort of minimise the chance of putting a PGR on, and just it so happens that the environmental conditions mean that the plant isn't very responsive to it. So putting on a PGR at growth stage 30 and growth stage 31, 32 is, I think, splitting it is important. The late PGRs are very effective at growth stage 37, particularly in barley, but mixing the actives as well is important. You had the improved
Tillering effect.
Yeah. Now, gibberellic acid inhibiting type PGRs do reduce apical dominance, and that can increase the amount of tillering. I've never seen it increase the tillering to such an extent that it can increase the lodging. So I think it can help sort of boost ear number and yield a bit. I've seen quite a bit of evidence of that in Corma quat. It's often not statistically significant, but it happens so often. But I think there must be some small effect of some of the PGRs to increase tillering and ear number. But I've never seen them to do that to an extent that they actually increase the risk of lodging. The shortening usually, or always in my experience, overcompensates.
Good. You didn't talk about nitrogen. We talked a little bit about nitrogen. The one question everybody's asking us at the present moment is that with inputs so high, is there an optimum level that we can go to that still produces a yield and still reduces risk of lodging without going to the actual optimum levels of nitrogen?
I mean, we have been doing lots of work on this recently, as you might expect, looking at all the nitrogen response curves. And what we've sort of studied the nitrogen response curves to work out what the yield impact is if you have bought at a very high price of nitrogen, which many, without no fault of their own, have. If you reduce the the nitrogen rate by 50 kilograms of N per hectare from the economic optimum for spring barley, for example, then that will reduce the yield by not as much as you might expect. It's about 0.5 tonnes per hectare. So this is, say, RB29 or whatever recommended system you're using is, let's say it's recommending 160 kilograms of N per hectare for feed barley. If you reduce it by 50, our end response curves are showing that that reduces yield by 0.5 tonnes per hectare. Not as much as you might expect, you know. So I think there is some scope for pulling back, given the high prices of fertiliser, and still being profitable. And we know from the work I've just shown you that reducing by 50 kilograms of N per hectare will effectively increase the lodging resistance score by 1 point. So I think there's a happy balance to be had somewhere in that. I mean, George, I suppose you're thinking you're all malting barley up there, aren't you? So I guess the end rates can't be that high. I think you've just got to sort of look at it on a case-by-case basis in many respects to judge what the optimum is. But I think what we're trying to do is provide farmers and agronomists with the knowledge of how much yield they lose if they reduce below the optimum, and what the impact on the lodging risk is, so they can get that balance right for their crop.
Yeah, the other important measure to take into that is residual fertility as well.
Yeah,
which
yeah, sure.
Taken into consideration before, and you know, somebody ploughing out of grass is going to get a high lodging risk before they even start putting the crop into the ground. So there's a whole array of different other things there. Sorry, Pete, I could take the whole session for questions.
Yes,
if need be, like, but I mean, practically now, I think we are getting on top of the lodging element. The Brackling one's slightly different in that with the change of weather patterns and things like that, we are finding in Scotland that we're getting more Brackling now. Getting near harvest and getting intense rainfalls and things like that gives us this big problem. So no matter how clean we keep the crop, we are starting to find that we are getting this Brackling problem, which, you know, is giving us concerns. So yeah,
I think there's more work needs to be done on Brackling myself. You know, we've scratched the surface here, and it is a big problem, like you say. And I think there's other factors which are affecting it, which we don't understand. You know, I've seen Brackling occurring as a result of certain weather conditions. You know, if it goes very hot for a couple of days, I've seen Brackling occur, you know, straight after that. It really weakens the top of the stem. So there's a lot of work we could do, I think, to get to grips with Brackling.
Anyway, we're getting near the 3 o'clock. We like to keep these sessions between an hour and 15 minutes. So Pete, thank you very much for your input today. Very interesting, and I think you've probably with the work you've done, we've probably raised more questions than answered, just because it is a fairly new thing that we've been looking at. And I think there is the opportunity to go to the poor man's barley, as you talked about, go to the winter crops as well, because there's more and more winter barley being grown, and we're looking for markets for that as well. So
definitely, yeah.
Thank you very much, Pete. There is the opportunity to go onto ADAS's site and see more of what Pete's work's been doing. I know a lot of the stuff that Pete's been doing over and above Brackling, and actually nitrogen inputs and things like that. There's a lot of work being done there. So I'd advise you to go onto ADAS website and have a look to see whether there is anything else that we can glean out of this. So Pete, thank you very much for your informative talk. I hope to get down to England to see you again before very long. And again, you're more than welcome up in Scotland again. So
thank you, George.
Catching up soon.
Thank you, and thank you for all the questions as well. I very much enjoyed the discussion there. Thank you.
Okay. Just to give you a quick update, our next seminar is the 21st April. And as I said, these are very technical seminars now. So the speaker presentation is from Oregon, the seminar titled Barley of the Future. So it's looking at different flavours from naked or So we're looking there. So we've got Dr. Patrick Hayne and Ellen Branham and Chris Mason are our speakers. So you should be able to lodge on that now. I got my invite yesterday through, so you should be able to lodge on to that there. And we look forward to seeing you at our next seminar. So I round up this afternoon by thank you very much for your attendance, and we look forward to catching up soon. Thank you.